Hi, my name is Matthew Anderson, and this is my Lab 4 lab report for Physics 1, and this lab is Oscillations. So the purpose of this lab was to predict the motion of an oscillating mass with observed tracker data and to create a computational model to replicate this motion, and then to analyze the different motion types of the system, which contains the spring and the earth, and to include mass in the system for calculations. And a preview of the results is that there's a slight discrepancy between the observed and modeled results, likely due to external forces that were not included in the model. So here are the initial conditions. It starts at time 0, and that's my y position, 0 velocity because it's from rest, and we have the given mass video, period of oscillation determined, and spring constant and initial stretch all determined with methods presented through videos. The key concepts, mainly the energy principle, delta E of the system is equal to the work of the surroundings plus Q, being the exchange of energy between the systems and surroundings due to temperature differences. We're supposed to consider the mass, spring, and earth as a system, so then there's no work done by the surroundings and energy is conserved. We have kinetic energy is equal to 1/2 mass times volume squared, velocity squared. Then the gravity, potential energy of spring formulas here, 1/2 spring constant times the times the stretch squared, and then potential of gravity is mass times force of gravity times the difference in y, and then we have energy principle, the change in kinetic energy plus the change in the potential energy of gravity plus the change in the potential energy of the spring is 0. Energy is conserved. So here's my tracker graph. Got the video and just tracked every point manually. And moved the X and Y into a CSV file to using little script analysis, which started at frame 5, not frame 22, like the video says. And here is the glow script model that we made. As you can see, entered in the derived constants from the video, and then had to change some lines here with the energy principle and kinetic energy, potential energy of gravity in the spring, and energy principle there. And we had to define some things and update the position here. And you can see where we actually calculate the changes in energy. So here are the results. As you can see, there is just a very slight difference between the model and the experiment, which is likely due to external forces which were present in real life and emitted from the model, air resistance and drag. Obviously, a model is a model. You can't take it as reality. Some things are going to be omitted. And then tracker user errors, of course. It can be quite difficult to completely precisely place your little tracking nodes there, so that may cause slight discrepancies in your calibration and the tracking, but otherwise quite similar. Definitely success. What does it mean? Is the energy principle satisfied? Yes. As you can see, the orange line in the middle is the energy of the system. It stays constant the whole time. This energy is always conserved within a system, not lost or gained. Energy principle is the key thing here. And what does it mean? X and Y oscillations. So as you can see by calculating period of oscillation, they're quite similar, but there's still a slight difference, which is most likely due to errors in precise nature of placing tracker points, but for all intents and purposes, they're similar enough to consider it a success. And that is all.